Hey folks, how's Build so far? How was the keynote this morning? People afraid of agents already? No? My name is Scott Hunter, and I am here. I got a lot of folks here in the front row. Divya, stand up, please. Logic Apps team, she's going to do a demo. I've got Tim. He's going to show us how to modernize our code. Got Nick. Nick's going to show us the SRE agent. And we've got Eamon. And he's going to show us how to do functions in AI and functions. Michael's actually one of my producers, and he knows I hate all this AI stuff. But I mean, can we have a build talk without AI? But I'll laugh and say, you know, a year or two ago, I really felt strongly about that. But this last six months or so, the AI stuff has really gotten good enough that I can actually see the usefulness of it for the work that we do. So three kind of things here is like, you know, we've been adding AI to existing apps, and I think we're going to do build AI native apps, agents in the new world. You're going to see how we can use AI to do DevOps, and you're going to see, you know, how we can accelerate everything, make your lives better. It's pretty cool when we think about the tools that we have. 50 million developers using our Visual Studio tools that are all Copilot enabled. But we've got other cool stuff too. We've got the Copilot and all this stuff that we're going to show the agent modes, right? That's Tim. It's available in Xcode, Eclipse, and all the JetBrains IDEs as well. So some of the stuff you're seeing here works there as well. 150 million developers using our DevOps solutions, and Copilot, GitHub Copilot's growing like crazy. You're going to hear a little bit. Nick's going to show us how agentic DevOps is the new norm. A lot of the things that you would do today, monitoring your applications and stuff like that, can be done with AI, still with you in control. There is no, you know, everything we're going to show you, you're going to see the human is fully in control. We're not letting the AI go and do autonomous stuff. And then also, you know, our Azure PaaS services are the best place to host all your apps, AI or non-AI. And we're going to show some of the improvements that are made there. And we think we have the best stack from tools to platform for building AI apps at Microsoft. I'm going to go through this fast, Michael, so these folks can do. We have a lot of demos, so I hope if you're coming to see coding demos, we have tons of those. This is real world stuff, and there's actually, if you can read the micro text at the bottom of these things, you know, this tech enables you to develop apps faster, get your apps on market faster. These all say the same thing, Michael. These three, they all say the same thing. Oh my gosh. Anyways, let's get to real world stuff here. How do you modernize apps to PaaS? And you know, I think, you know, our PaaS solutions that we build, my team builds all the PaaS solutions at Microsoft, whether it's App Service, Azure Functions, or container apps. These are all meant as ways of running your apps in Azure with less work from you. The platforms will update your code automatically, update the runtimes automatically, the OSs automatically. They do lots of stuff for you. But one of the things that we hear from our customers is moving an app to the cloud takes a lot of work. And in some cases, we hear it takes 8 months. And so a bunch of us have been trying to figure out how can we make that migration to the cloud faster? How can you migrate from something to something? And so I'm going to talk deep about that in a second. But let's go quickly through all the things we have in our PaaS platform that are new. This is a new SKU of App Service. You can see 25% improved performance. It's cheaper, and really it's cheaper is what I would say. But more performance. But what do you care about? Cost. And so we haven't changed App Service pricing in a long time. So this is a much better price SKU of App Service for your new applications. Super excited about this stuff. You know, as we talk about all this AI stuff. You know, if you go and buy a GPU in Azure, it's quite expensive. And so Azure Container Apps now has support for GPUs. And these can be serverless. And so we had a customer in another part of the world that they were using full-time GPUs at Microsoft in Azure. And so they wanted to get every dollar out of those GPUs. And so they divided their team up into 3 shifts that had to work in different 8-hour time zones, so they were actually using every part of their GPUs. And they want to go move to serverless GPUs because if they do that, they're only paying for what they're using. And so now they can actually do all of it in an 8-hour window and only pay for what they used versus having to have those GPUs full the whole time so they're not sitting idle all the time. And so this is all GA as well. Dynamic sessions, which is something that we shipped a while ago. This is how you run untrusted code in the cloud. Basically, we give you a VM, we run your code on it, and then when you're done, we throw the whole thing away. You can see we have, in private preview, we have support for GPUs here now as well. This is great for AI workloads where the AI might actually change the machine in some form or fashion as it's running code. And you can see here as well, you can also use these to run some of the models in the AI Foundry on your behalf. I'm a big fan of this stuff. One of my developers used this because he was developing against OpenAI, and he hit his token limit in about, I think it was under a minute, because he was using, he has a really cool app that actually builds, it's a book generator. And so you fill in a bunch of questions, and it goes and generates a book. And he was able to use the serverless GPUs as just for development. And so compared to the cost of using a full GPU, a full expensive GPU, it cut his cost down by 1/8. It was 1/8 of the cost of the full GPU. So it's great for developer scenarios too. Azure Managed Redis, super excited. This GA today. If folks don't know, we've had Redis in Azure forever. And it was really complicated to figure out how much CPU or how much memory you want to use. The new Azure Managed Redis, very simple. You tell us how much memory you want and how much CPU you want. And pricing is very simple. There is no longer you have to pay for a premium or any of these SKUs. You get all the features and all the versions. You just set the slider to how much memory and how much CPU you want. And so it's probably a half, if not a third, price-wise compared to the old managed Redis that we had before. And it's actually super fast as well. So it's faster, cheaper, way more, all the features, and you can set your memory and CPU. This is super exciting. MCP. MCP is a funny thing. I was actually, I don't think Paul's in the room anymore, but Paul Yuknovich, who works on functions, I sent him an email one day, and I'm like, hey, we should look at this MCP thing. And we work for Jay Parikh, who runs the AI team at Microsoft. And literally, Paul ignores me. And then on Saturday, Jay sends this email. And then on Monday, we're all doing MCP. I'm like, I tried to give you a couple days head start. But MCPs are how you extend LLMs. And so I'll give you an example of how I use MCP myself. MCP is like I'm in VS Code, and I have got the GitHub MCP server installed on my device, and I've got the Postgres MCP server installed on my device. That means I can just go and say, in the chat, I can say, file a bug on Tim that this demo is too complicated. And it can go and file that in GitHub for me on my behalf, just asking in text. I could do cooler stuff. I'm building my Aspire application, and I'm like, build me a web form that contains all the fields in this table. And it can go out to my Postgres, read the actual database columns, come back to the AI, and do that kind of stuff. So MCPs are cool because you can teach the LLM how to do things. Some people call these things agents. To me, they're not that yet. But we did a whole bunch of stuff in this space. We've got API Center, which is part of our API management product. It's got a place where you can put all the MCPs that your organization has, and so your developers can go and find them there. We have, in API management, we also have a really cool feature where you can take any of your existing APIs that you want to make into an MCP. You can literally go in and just check a few boxes, and no code changes at all. We can convert any of your APIs into MCPs if you want to. And so lots of cool stuff in this space. And with that, we're going to talk about one of my most favorite topics, the one I was mentioning earlier, which is how do you modernize applications? And so there's a couple things here that I care about. Number one is how do you stay on the latest versions of stuff? I want to be, maybe I'm on Java 8, I need to be on Java 21. You want to be on that latest version because you want to be compliant with Azure, and at some point we won't support Java 8 anymore. The other scenario is maybe I want to move to the cloud. And let's say I'm on my local machine. I've been using, on-premise, I'm using RabbitMQ, and I want to move that to like Service Bus. Well, today what I would do is I would call Tim up, and I would say, Tim, go please change 700 files to use Service Bus instead of RabbitMQ. The tech we're going to show you today actually lets you go and automate these kinds of things. So we can go do that modernization for you, fix it once, and then we can do it for you a billion times. And so I'm going to bring Tim up on the stage and do a awesome demo of modernization. By the way, we're going to show all this stuff in Java. Tomorrow there's a session where we talk about how you do all this stuff in .NET. So don't think that we're just crazy and only Java people. Everything we're showing you, we have a .NET flavor of as well.
All right, thank you, Scott. Yeah, like Scott said, I'm going to show you stuff in Java and in VS Code. Tomorrow, Scott's going to show some stuff in .NET, and we are also going to be launching support for IntelliJ if you're a Java developer using IntelliJ. So that's kind of just the baseline for where we are today. So I want to demonstrate to you, if you were in the keynote this morning, you heard Satya talk about upgrade and about modernization. To us, they're kind of the same thing. One is, as Scott mentioned, upgrading your SDK frameworks and all the dependent libraries, and the other is about moving your application to Azure. So I want to show you how GitHub Copilot app modernization helps me as a developer understand my application and then migrate my application to use Azure efficiently. So here I have an application. It's called Asset Manager. It's a Java application. It helps me manage assets in my company. It's a simple application because I want to make sure all the demos run in the time that we have. I am not very familiar with this application because it's been a while since I've looked at it. And my company has many, many of such types of applications. So let's see how GitHub Copilot app modernization helps me understand my application better. I have it installed here in Visual Studio Code. So there's this little icon here. And I'm going to first start by kicking off an assessment. Okay, so it's going to go and ask me a couple of questions. So we're using GitHub Copilot agent mode to do this. And it's going to go and ask me. So I'm going to start it because it takes a couple of minutes to run. So an assessment. It helps me get to know my application a little bit better because, as I mentioned, I might not be super familiar with it. This is very helpful for me before I start doing any kind of design or architecture or code changes. I kind of want to know what I'm up against. So app modernization helps me. It summarizes the application to help me get a better sense of what I need to do. So here, you can configure the assessment in a variety of different ways. I've just accepted the defaults because for the demo, it's a little bit easier. So the way app modernization works is that it is going to do source code analysis. And this source code analysis is going to discover insights such as what are all the dependencies and frameworks and SDKs that my application is using. Are any of them out of date? Do any of them have CVEs that are issued against them? What are the code patterns, maybe common configuration patterns or security patterns that my application is using that I need to update it to be cloud ready? Am I using any on-premise services for which there are Azure alternatives that are better for my application to use? In other words, it's kind of like, what are all the things that I need to do as a developer to make my application run well, securely, and easily on Azure?
I was going to say, on Azure, the big thing is it makes your app ready for Azure.
That's right.
Yeah.
Cool. So here it's done. And what it's done is it's kind of like created a set of issues for me. And it's summarized these issues. So if you've used AppCat, AppCat generates a ton of issues. And what we've done is we've taken all of those issues and summarized them in a way that is kind of targeted towards me, a developer, for the tasks that I need to do. Each issue has a criticality assigned to it. So I can kind of get a sense for what we think is the most important things to tackle, so I could plan my work accordingly. For each of these issues,
clear, this was a static analysis tool before.
This was a static analysis tool.
You would run this tool, and it would generate a huge file of stuff you're supposed to give to your developers.
That's right.
We're showing that people didn't like that. Hey, Tim,
right.
Here's 1,200 lines of assessments of things you should change for your app to go to Azure.
Right.
The idea here, you're getting a good visualization, and now you can just select the one, and the AI will actually go and do the work for you.
Yes, so I could go ahead and propose solutions. And so here, what we've done is we've looked at the issues, and we look at what are the possible solutions that we have to offer for you. You can see that there's a lot of different solutions that we offer. Sometimes there are multiple solutions, and we can pick from them. And so here, I'm going to focus on the database one today, just for this demo. I'm going to uncheck the other ones. And what this is going to do is this is going to help me leverage Azure SQL with managed identity. One of the things that we hear most from customers is that when you move to the cloud, adopting managed identity is a very important security posture to take. And so we're going to see how that works. So I'm going to confirm it. And now I'm going to hit this migrate button. And what this is going to do now is this is going to send an instruction to GitHub Copilot, and it's going to ask GitHub Copilot to run this migration task. And so it's going to confirm the plan. So GitHub Copilot comes back and says, like, hey, here's the things that I need to do. And I look at it, I'm like, that's great. I'm going to continue. It's going to do the first step of the plan, which is what are all the files that needs to be changed, right? And so here it's discovered some of these files. I'm going to say, great. And then now it's going to run. So now while this is running, I want to take a couple moments to explain to you what's going on underneath the hood. The way app modernization works is that it enhances GitHub Copilot agent. Okay? There are two things that we do. The first is we provide a suite of tools. And you can see that when you kind of click on the tools. And Scott hinted at MCP tools. And so here are all the tools that we provide. And we provide these tools that kind of enhance the way GitHub Copilot interacts with migration scenarios in Java and then eventually .NET that you'll see tomorrow if you attend Scott's session. We provide formulas that these tools use. Formulas contain knowledge, best practice, code samples, rules, kind of like do's or do nots, that are really oriented to help you migrate your application to Azure. So if you look at these formulas, they're usually kind of like a from A to B type of pattern, right? Like here, we have kind of like from RabbitMQ to Azure Service Bus. Or here, there's like a, migrate to Azure Key Flow. So these are kind of like formulas that supply the agent with additional information. The second thing we've done is we've built a user experience for you over here so that you don't have to figure out how to prompt the agent. Because sometimes I don't know if you've used the agent mode a lot, but sometimes it's hard to figure out what are the right things to tell it to get it to do the things that I want it to do. And so what we've done is we've packaged that into a nice user experience. So you just pick the formula that you want, or you drive it from the AppCat issues selection, and you just hit go. And then we kind of figure out all the things for you. We provide many migration scenarios here, and we're going to continue to add more. All of these are tested with Microsoft best practice. We have another session on Wednesday in, I think it's breakout 131, where I'm going to go into more detail to show you how you can customize these formulas and even create your own so that they can capture your enterprise best practices. OK, so GitHub Copilot's done. I can review the changes, right? So I can go here and I can take a look at the different changes I just made. And it all looks good to me. We also offer a build fix loop, so you can kind of go and say, like, OK, I want to make sure that it builds. And if it didn't build, we would use AI to try to identify build issues and fix them for you. But in this case, it should build. And so we'll wait and see. It's just doing a Maven build. And yeah, so the build was successful and no errors were found. And here we can summarize all of these issues. So that's it. So this is how GitHub Copilot app modernization can help me understand my application and quickly make code and configuration changes to make my app run on Azure.
That's pretty cool. So he just converted an app from connection strings to manage identity.
That's right.
He never wrote any code. He just approved what the agent did. And as he said, we're going to have a whole bunch of these kind of things that'll help you move from Azure, on-premise to Azure. Right. And then what I'm really excited about, too, is you can make your own formulas, too, right?
That's right, yes.
So I could go and, I was telling somebody, if you want to move from library A to library B in .NET or Java, have your developer do it on a couple of files, and then we can then make a formula from that and repeat it across the rest of your code base.
Yeah, and that takes a little bit longer to show, so we're going to do that in session 131. But yeah, cool. Thank you, Scott.
Cool. Thank you, Tim. OK, let's just jump right into SRE agent. So SRE stands for Site Reliability Engineer. And these are people who basically monitor your applications. This is what I would call modern DevOps. You've got these people that are making sure your apps are doing all the right things. Is the app running? Is the app crashing? Is it using too much memory? Is it using too much CPU? Is it on old libraries? And so on. And so Satya mentioned this briefly in the keynote. It was on one of the slides. I was super excited to see it. And the idea is, if you're running a service in Azure, we want you to use the SRE agent as a way to monitor your service and make sure you're getting the best experience you can. And so, Nick, you want to come up and do a demo of SRE?
Cool. All right, hey, everyone. Can you hear me OK? Perfect. OK. Yeah, so quick elevator pitch. SRE agent is a new Azure service that reduces the cost of your team's operations and improves the reliability and availability of your apps that are running and deployed into Azure. And so I'm going to show two demos today. There's two different ways that I like to use the SRE agent. One is proactively, and what that means is I can proactively prompt my agent to look into certain behaviors of my applications. And then the other is reactively, where I can set up my agents to respond and react in real time to incidents that might happen, where it can run a root cause analysis and mitigate those on the spot. So let's jump right into the demo. On my screen, I have a IoT application deployed into my subscription here. And this IoT application has a front-end UI dashboard that pulls in the IoT state from each of our devices. So in each one of these cells here, you should see a status of an IoT device, which represents an employee workstation, right? And so the state of these IoT devices is stored in a back-end Redis instance. But as you can see, there's a connection issue from this container app with this dashboard is running to the back-end Redis instance. And so this is exactly the type of situation where I can proactively prompt my SRE agent, why is there a connection issue? And so let's do that now.
The stress of typing.
Yeah, on the spot. OK, so let's hit enter. And so while this is going, this will take a couple seconds, but I want to show there's this resource mapping. And so this is basically the SRE agent that I have deployed into the subscription. I've given it management control of resources that are all a part of this IoT application. And I can see that here, and how these resources are interacting with each other. And right off the bat, I can see that this container app is marked as unhealthy. So my SRE agent has already diagnosed that there's something going wrong with this container app. And if we go back to our thread here, my prompt, my ACA app IoT is experiencing connection issues. And so it does a root cause analysis. And so it actually goes through this whole workflow looking at the state of this container app, looking at metrics, looking at availability, request volume. And so you can see just that, right? So I can see memory looks good, right? Memory's low. Request count, still low, just from my testing, right? And so it's moving on to the next step. In this case, it's looking at network configuration settings, right? And right off the bat, it's found that there is a NSG rule called deny on a certain port that is blocking outbound traffic to my backend Redis instance. And so it's at this point that this is a misconfiguration. And so the SRE agent has identified this, right, within seconds, and is asking if it would like me to update the configuration of my container app to remove this blocking rule. And so I open up the right-hand side here. I can actually see, as Scott mentioned earlier, it's not doing anything without my permission, human interaction, right? So it's asking, do we want to remove and update this rule? And I will approve that. And so you can see the actions that it's taken on the right. It's pending the approval.
I just want to highlight again, you saw him Nick scroll through all these things. That's the stuff that you would actually ask somebody in your team to go do manually before.
Exactly, and take a long time.
And it would take a long time. It's like all those steps he scrolled through, the SRE agent's doing that work in the background on his behalf. So instead of him doing it himself, he just waits for the root cause to come up, and then you can decide whether you want to accept or decline that.
Exactly, it saves me a bunch of time, right? And so here you can already see this app is fully recovered. I can see the state of each one of these IoT devices. And so again, this is just an example of how I can proactively prompt my SRE agent to look into issues or behaviors that I'm seeing. I can also ask it to evaluate my application, my resources for best practices, and it can tell me, am I following best practices? If not, it can update my resources to do that. Cool. So I'm going to show another a demo. This is showing how to use the SRE agent in a more reactive-like setting. And so for both of these demos, I am investigating applications that are running in container apps. However, the SRE agent does integrate with all of the Azure Compute services we have today. So web apps, AKS, container apps, functions. So you can use it in those services as well. So for this reactive demo, I have another app deployed in the container app. And this app allows us to test various behaviors of our applications and the resilience of them with the SRE agent. So you can see here, I can create deadlocks in this app. I can consume CPU. I can even consume memory. And what I want to highlight is not necessarily a configuration issue. What I want to highlight is an issue that only arises under specific circumstances or conditions. And so in this case, what I want to do is simulate a memory leak, right? And so before I do that, I have this container app currently integrated with an incident management tool called PagerDuty. Is anyone here familiar with PagerDuty? Yeah? Yeah, so PagerDuty allows me to set alerts for when my application experiences a certain behavior. So an error threshold is hit or it becomes unreachable. And the idea is that I have this container app hooked up to PagerDuty, and I have my SRE agent integrated with PagerDuty. And so if you think about, when is this a good situation? Well, if you're that on-call engineer that's currently, when an alert gets fired, you have to pick up the phone in the middle of the night and debug these issues live. Well, don't worry, the SRE agent has your back, and it's going to be able to do these things for you. So let's do that. Let's consume memory until my container app actually falls over. So I'm just spamming that. And at this point, I've simulated a memory leak. I'm actually seeing 500s being returned from my container app. And unfortunately, I'm on call right now, and I'm getting this alert. But like I said, I'm going to snooze it and let my SRE agent friend take care of it. So this alert will then be brought in to the SRE agent, a new one that I have deployed into my subscription. And again, we have the resources that we can see here that this agent is managing. And I also have settings. And this is where I've plugged in my PagerDuty information. So here I have my API access key, and that's all that's needed for this integration to be enabled. And if I go back to my threads here, we should see one. It does take anywhere from 20 seconds to 30 seconds. But oh, there it is. It just popped in. So it actually takes the alert from PagerDuty, brings it in, and starts a new thread with my SRE agent. And it uses the information from that alert as the prompt to this thread here. And so at this point, my agent is starting to investigate, and it's running that whole root cause analysis. Again, something that takes a lot of time, right? Knowing where to start. And it's going to go through all of the different, checking the metrics, the health of the app. It's going to look at the configuration for network settings. Here you go, right? So it's going. But let's jump over to one that had already finished, and we'll just walk through what it had done. Let's see if it's this one we can use. Yeah, let's look at this guy. So in this case, it detected that there was a memory spike in the application. It identified that it was a .NET app, and so it did a memory dump on our behalf. Again, another task that can take hours and days to do. It did this within minutes. It recognized that this situation isn't something that can be solved with just a configuration update permanently. It actually needs a software engineer to go in and update the source code. But what it did as a temporary mitigation is it actually scaled up my container app for me in the memory. So I have a max replica set of 3. It scaled from one replica to 3, and it bumped up my memory. So it knew that it could temporarily mitigate this issue until someone was able to actually fix the issue with a more permanent fix. And speaking of more permanent fix, it raised an issue in a GitHub thread that I have tied here. And so this is the issue with all the memory dump information of that whole analysis, what it did to temporarily mitigate it, and then recommendations for next steps. So as an on-call engineer, or the software engineer that's coming in and solve this the next day, you have everything that you need right here for you. A lot of your work is already done before you. And then lastly, there's a deep link here that you can jump back into the thread, and you can look at that history, that whole analysis that the SRE agent had done on your behalf. Cool, so those are 2 scenarios that I want to just highlight, how you can use the SRE agent proactively to ask it to look into certain behaviors that you might see with your apps, or to audit your apps for best practices, and then how to set it up to be reactive, where it can respond and mitigate issues as they happen in real time. And this SRE agent is in early access now, so we'd love for you to try it out, and let us know what you think.
Yeah, and we use this internally.
We do use this internally, right.
So we're using this internally for ourselves, and for the same reasons that Nick just showed, just all that work that we just saved by doing that. Okay. That's not good. Well, doesn't like that one slide, Michael. Okay, well, we'll skip that slide. Okay. Why don't you just come up, Eamon, since that slide died. That's a great way to intro that thing. What we want to show now is we want to show we have great support for AI in Azure Functions. And so Eamon's going to come up and show us how he can do typical real AI things in Azure Functions with almost no code. And I think we're also going to show some MCP here as well. Azure Functions is a great way to do a remote MCP. And you can do it securely. There's security attached to Azure Functions, so you can actually hide the thing behind authentication, which is really cool. Sorry that slide died, but.
Oh, that's awesome. Yeah, there's so much going on. I think the biggest thing I would say, Scott, is I think one of the challenges with agents is you already have all of this systems you have in your environment. You're able to integrate with them already using app service and functions and everything else. But how do you expose them out to these agents so that they can actually take advantage of all the work you've built up over the last 10 years of building out these and integrating systems? And that's really where MCP kind of comes into that, its own, is that it gives you that interface for agents to be able to get access to all the code and all the systems you guys have built for like 20 years. So that's what's kind of exciting about it. It opens up, and like, what's your role when you think about agents? If you can expose your systems out through MCP to agents, now you can actually start to build these agents in your organization by taking advantage of all these capabilities you guys already have invested in. So what I'm going to demo here is, there's a quick screenshot there, but it's going to do two things real quick. One is, you have a lot of data in your organization. How can you ingest that into a semantic database like Cosmos DB I'm going to show? We do support AI search and others. How can you bring all of that data in? So now you can search it for whatever agents you're trying to build. They have access to all that aggregated semantic data. And then the second thing is, how do you expose that out for agents using MCP with Azure Functions? So let me jump over. Hopefully it will show up. There we go. OK, so basically what I'm going to do here is I'm going to first import the data, and then I'll talk a little bit about how the code in Azure Functions works. And hopefully if you're familiar with Azure Functions, it'll look familiar. If not, there's not a lot of code. So hopefully you guys can try it out as well. OK, so the first thing I want to do is
just quick test. Can people in the back row see the code, or is it good? OK, perfect.
Awesome. So I'm going to ingest the data. So I'm going to basically ingest some support data. I'll just run it. But what this is doing is I have functions running locally here, and I've ingested some support data into Cosmos DB as a vector database in the backend, just with that one line of code. Obviously, from functions, because we're basically real-time RAG, if your data's in blobs, it's in a database, it's in event hubs, it's in anywhere, we already have all of the ways to integrate into all those systems, so you can bring that in and just send it automatically into your choice of semantic backend database. So once you've ingested it, so obviously you can imagine you can ingest data over and over and over again. You can then expose this out so you can ask questions of it. So I could send a request here. And now you can get back that information directly out of all the data you've ingested into your organization. So think about, you have this API to import stuff. You have an API to ask questions about your data. And that's great if you were building like chat systems, API, websites, and you want to be able to just call those and be able to expose this out to your environment. But what happens if you want to kind of expose that as an agent? So I'm going to kind of show a little bit about what that looks like in code. So when you look about Azure Functions, I'm first going to show you how we kind of ingest the data. So you can see here we have basically a HTTP endpoint. So that's all Azure Function can stand up as a HTTP endpoint. But what we've built is we've built an extension called the OpenAI extension. And what that allows you to do is it allows you to automatically store all of this data into the vector database of your choice. So in this one, I'm using Cosmos DB. You could use AI search. You could use MongoDB with Cosmos DB, or you could use Azure Data Explorer. And through config, you can basically specify this is raw text. It could be coming from a file. It could be coming from a URL. And then you can specify with environment variables, where do you want this to go? So this is my Cosmos DB connection. I have a container called RAG, and I want to know which embedding model am I using. So these are the OpenAI different embedding models. And literally with this amount of code, and it works in all languages. I'm showing C# here in .NET, but any language you want to use, just with this code, you can import data in real time and put it into your semantic backend.
So just an API and an attribute, and you're kind of ready to go.
Literally, that's about the code. You can see there's really nothing to it. And then you can, when I was doing that prompt, I was asking questions about it. And you almost do the reverse. Now when you ask questions, you take the question from the query, and again, we just go automatically against those systems and return the results back to you. So that's the end of the function right there.
So that's OpenAI in like 20 lines of code, really.
Literally 20 lines of
10
code.
lines to put the data in, and 10 lines to take the data, to get the question back
and
out.
in real time, because it's functions, event-driven, no matter where your data is, you can pull it in, and you can send it into that back-end vector store that you've chosen, and get all of that data available for semantic search. OK, so great. You've got it in. You've exposed it through APIs. But what happens if you're building agents in your org, and you want to expose this out to them so that they can also use this inside of their agent flows? You're building a support agent, and you want to expose this out. So what I've done here is we've introduced the new binding called the MCP binding in Azure Functions. And it basically has the ability for you to decorate your function to say, I want this to be an MCP tool trigger. And so just literally with the decoration here, again, this is in .NET, works in all the languages. But you can see I basically just decorated with MCP tool trigger. And what MCP tool trigger tells the Azure Functions service is, I want this to be an MCP, but not only expose this function as an MCP, I want you to turn this entire function into an MCP hosted server in Azure. So now you can actually stand it up, and you'll see it available. OK, so it's right in there. It's get support information, do search text. But let's see how we could actually run this thing. So I have mcp.json. It's empty. I'm going to just get my local environment. I will just save it here. And you can see it's running down here. So I'm going to hit start.
So you're running the MCP server locally on your machine right now?
Literally, I hit F5. If you're familiar with Azure Functions, full host control, full debugging, everything's local on your machine. It's just pointing to literally local host that's running down here with Azure Functions.
If folks don't know, we have VS Code support for MCP servers, and we just last week shipped MCP support for Visual Studio as well. So you have agent mode and MCP are both in VS Code and Visual Studio.
That's right. Yeah, I saw the Visual Studio stuff. It's awesome. So I can now ask a question, just like I did before, but now I'm going to ask it through agent mode. So obviously, I'm running agent mode in VS Code. And I'm going to say, get today's information about 3455. And you can confirm that the tool is available, get support information. So what I'm hoping will happen is the agent is now going to say, OK, what tools do I have available? Oh, I have ability to get support information. So now I've exposed out all that data that's been imported out to agents to be able to use. And obviously, if I can get confirmation so that it can be done, obviously, you can set it for this session, all sessions, always. I like to always get confirmation. And what it's going to do, it's just going to run. And you can see I'm straight into the debugger. Because everything is local. You get that full, rich experience. So you can debug it just like you would want to do normally. You can see the result. And I'll hit F5. I know we're almost out of time. So that's almost running. So I'm going to do one more quick thing. This is great. It's all running local, like Scott said. But I also published this to the cloud. So you can see here, get support information and the two other HTTP triggers I built. So let me just see if I can point this to the cloud. So I'm going to take away this, get my remote, so it points to the cloud. And all this is kind of standard stuff you would normally do. And when this starts up, let me just start it here. There, from there, now you're pointing to a hosted MCP server running in Azure Functions in the cloud, directly from whatever agent you want. I can create a new agent session, ask the same question, and hopefully it'll do the same thing, except now it's going to point to remote MCP server that's hosted in Azure. OK, so with that, hopefully that gives you a flavor of what we can do with Azure Functions, what we can do with MCP, how you can bring all your data you have in your organization, expose it out, either API calls, data calls, through our MCP interface. And plug, we do have a session on Wednesday. We're going to go deeper into this. If you want to see it, there's functions with AI agents. Love to see you there.
And I also, we didn't talk about the fact is, like, I always laugh. If we exposed like M365 as an MCP, our servers would probably crash within like 10 seconds. I mean, just think of as you hook this stuff up to these LLMs, how do you scale?
Yep.
Well, there's no better way to scale than Azure Functions.
Yeah, on demand.
And so,
and you only pay for what you need. So
and you pay for it's
Yes.
serverless. You pay for what you need, but we can scale up and down as fast as you can. So this is a great way to host MCP.
awesome. Thanks a lot, guys.
Now, I've got a crazy question for you and or Nir. How long did it take us to go from 0 to having this built? It felt to me like it was 2 weeks to me.
I know you mentioned earlier that when you pinged Paul and said, like, this MCP thing is taking off. Can you guys look at it? I think within a week, with the dev team and ourselves, we literally had something working locally. And a week after that, we actually had a preview out where customers could do it.
I was going to say, so we went from 0 to public preview in 2 weeks. I have never seen us ship something that fast ever. So
Yeah, no.
congrats to you and the team. That's amazing.
Yeah, no, it's awesome. Thank you.
Please try this stuff. Final one of these is I want to talk about logic apps. Div is going to come up and talk about this. This is really, really cool. So I've already been a big fan of logic apps for a long time. There's a couple of logic app things to talk about. You can now write code in logic apps this week, right?
Yes.
Yeah, so if you've seen logic apps is this cool tool we have that has over 1,000 connectors to random data sources, and you can run workflows. It was all designed visually before. We now have support for writing these workflows in C#. So if devs feel like it's not devy enough, now you get the full
get
developer
everything.
experience
Yeah, codeful.
if you want. And we can also add AI. Well, first off, we've had AI support in logic apps for a while. It is great for one of my demos we did last year was actually taking an old application and having a logic app that went to the SQL database and did all the stuff that Eamon just showed. For making an AI database for us, so we could then go ask questions about the application without writing any code at all. In this case, we wrote no code. But now, today, we have agents and logic apps as well, right?
Yeah, we are announcing today Agent Loop, public preview of Agent Loop, which is a built-in capability to build AI agents in logic apps. So very excited to show that and talk about it a little bit more.
This demo is crazy, so I'll let you drive the slides.
Thank you, Scott. So as Scott was mentioning, today we have announced the public preview of Agent Loop, which is a built-in capability in Azure Logic Apps to build AI agents. And we are really excited about it because most traditionally, folks have separated workflows as something that you use for doing a very deterministic planned business processes, and agents are considered for dynamic complex problems where you need adaptive reasoning. But when you look at most real world problems, they are actually solved by bringing workflows and agents together. And that's where we are uniquely positioned, because we are able to provide you both workflows and agents in a single platform with all the enterprise capabilities, as well as an experience to build them which is very cohesive, all within a single platform, and lastly powered by 1,400 plus connectors which power your AI agents with all the right business context and data. So I think we are very excited about it, and we really look forward to see what you will do with these new capabilities that we have announced today. So without further ado, I'll jump into a quick demo here. So we have a scenario here, an auto loan approval scenario. And here in this slide, you see the current typical process where agents are not involved. When a loan application is received, it goes through a series of pre-processing in terms of extracting the data from the application, validating employment of the applicant, validating their credit history, credit score, and a bunch of other things. And then there is a team of human analysts that come into play who actually look at company policies, who have to access multiple different systems to analyze, to process that application, to make a final decision. And then finally, that decision is then communicated to the applicant, whether the application is received, is accepted or not, and if accepted, what are the next steps. Some updates are done to the CRM application and other things. Now, when I want to move this, if we move this scenario and try to bring in the agent here, all the manual activity, all the manual process that the team of analysts were doing, that was not a fun process. That was tedious, time-consuming process. Whereas where the real value lies is for this team of people to make high-risk decision, high-value decisions. And that's where the AI agent comes in and makes that possible. So in this demo, we continue to have a mix of a blend of a set of deterministic steps, which are being shown here in the blue boxes. But then the AI agent comes in and they bring in the continuous loop of reasoning and adapting decisions based on whatever is in the application. So let's jump into the demo here. All right, so here I'm in a standard logic app workflow, and we are going to create a new workflow first. For those who have used Logix, you will now see that we have a new kind of workflow, which is agent workflow. To create AI agents, you do need to create an agent workflow. Now, agent workflow supports everything that you can do in stateful workflows, along with the ability to build agents. When I open this workflow, it has a placeholder for a trigger and the new action, which is called the agent loop. Trigger is something that starts this workflow. Logic Apps offers hundreds of connectors to different services, to different applications. You can use connectors to respond to events that may be in the queue. You can use triggers to respond to records being added in databases or files being added to file share servers. So here we are going to receive the application through Microsoft Forms. So I'm using a trigger for Microsoft Forms that is going to return me the application that the user sends to us. Now let's jump to the more interesting part. So here what you see is the new agent loop action. The first step, like if you're building any AI agent, the first step is to associate your AI agent to an AI model. The way you do this is by creating a connection to OpenAI service. If you already have a connection, you choose that connection, and then within that you choose the AI model that is being deployed in your AI service. So you have full flexibility to bring in whichever AI model you want to choose here. I'm going to use GPT 4.1 here. The next step is to provide the agent with the instructions, which are essentially goals and outcomes you're looking from that business process. This is an important step because this is what defines the boundaries and guardrails for your agent to act and for you to get your desired outcomes. So you not just define what your goals are, you should also define what the agent should not do. And here I'm also specifying the agent, what are the conditions, what are the situations under which the agent shouldn't auto-approve or auto-reject applications, rather loop in the human. So like you've heard before in all the demos, looping in human, keeping in human in the loop is super important, and that we want to make sure is taken care of with whatever agents you're building. So with that, we have the agent, we have the system prompt that defines the goals. You could also define user instructions here, but I'll skip that for a moment. Now the next thing we'll look at it is tools. Agents are only powered by the tools they have access to, by the data they have access to. If you want to ground your agents, you have to provide them your access to your enterprise data, to your enterprise applications. And this is where you add tools here. And these tools, again, can be anything from hundreds of connectors that Logic Apps offers. So I'm going to use SQL as my first tool to get the details about the customer, if they have already an account with the bank and what does their bank standing looks like. So here you can see that I have two side panels. This is the action that I added to get the customer's bank history. And then we also added an agent a tool block, which is basically the tool block that contains different tools that you want to provide to your agent. For that agent, you have to give it a name and a description. So here I'm going to say get customer bank history. And I'm going to use the same thing for the description as well, but here in the description, you can actually go in more details if you want to provide more specific instructions to the agent. So once again, the name and description is super important because that's how an agent knows the purpose of the tool and will use it in the right time and in the right way. So we do this, and now we have a tool here. Let's add a second tool, and in this case, I want to add a tool to send a notification to the customer regarding the status of their application. So here I've used an Outlook connector and the send email action available in the connector. Again, you can see that we have option to configure the tool itself and the tool block. So I'm first going to give a name to this tool, send notification to customer, and we can use the same for description as well, or maybe in HTML format. So like you can go a little bit more descriptive when it comes to the description. Now another important feature I want to highlight here that we bring in through agent loop is agent parameters. So send an email is something where the agent is going to send customer email about both acceptance and rejection. So how do I purpose the same tool to do that? So in this case, that's where comes in agent parameters. By clicking on this, I am able to quickly specify whether a parameter value should be provided statically by the developer or through the agent parameter. So agent parameter is a way for developers to indicate that this value is going to be supplied by agent dynamically at runtime. Once again, for every agent parameter, you have to give a name, type, and description. And when you add a parameter, by default, we will, based on our Swagger, we will pre-populate these things, but you have flexibility to override them and give a little bit more description here. So I'm just accepting whatever agent parameter I got here, but here in the body of the email, I'll just say about application decision. So you have full flexibility in control, but at the same time, you have the power to use a combination of both static parameters coming in from you or coming in from the agent. So now let's talk about, we have added some tools here which allow your agent to get access to your organization's data to take action. I want to talk about another capability that agents need, which is around knowledge sources. Knowledge sources is what ground agents to your organization's data and policies. So here you can use any of the connectors essentially in Logic Apps and use them as a knowledge source, but we provide this curated list as a way to quickly find all the knowledge sources available here and use them within your agents so that to achieve your desired business outcomes and to ground them in your business data. So I'll, let me actually talk about one more thing. So like, as I'd shown you, I added a forms connector to make this agent autonomous by reacting to the application received from the customer, but we also support conversational agents. And the way you do that is by going through the channels and enabling the input and the output channels. This enables you to have the ability to then have conversation with the agents. So with this, you have the full flexibility to build both conversational and autonomous agents based on your scenarios. All right, so what I'm going to do is I'm going to jump to this finished loan application workflow. And as you can see, like we were showing you in the diagram before, it starts with a set of predefined steps where we receive the application from the customer, and it goes through verification and credit check. And then the application summary is being passed to the loan agent, who has access to the company policies through a knowledge source, who has access to the bank history, applicant's risk profile through the out-of-box connectors, as well as API management APIs. I'm also calling a Logic App workflow as a tool here to get a list of specialized vehicles which need additional human review. And then finally, we have tools to notify the customer via email. And the last one is where we bring human in the loop through Teams adaptive card when things need additional consent from the humans. While we are not showing here, you can also have another agent as a tool. So you can easily build, we are focusing on a single agent scenario here, but you can build multi-agent applications as well by chaining these agents together or having these agents as nested agents. So let's, and finally, after this processing is done, we again have a set of predefined steps in terms of doing some post-processing. So let's invoke this agent through two scenarios. So in the first case, I have a loan application for someone who has a good credit history and a good loan to income ratio. So we expect this application to be processed by the agent entirely autonomously without looping in the human. So let's look at the agent loop here and go into the run history of the agent. All right, sorry, let me go here, close this workflow, open it again here. Now, Logic Apps provides a rich run history that allows you to go back and trace the decisions that your agent takes and how it arrives to all the decisions. So here that the run is completed, and in here you can see the status of each and every step that was processed, as well as all the processing that the agent loop did. So we'll look at the agent chat. The agent chat shows you both the agent prompt as well as all the system prompts here. You can see all the tools that the agent used in order to arrive to a decision about the application. It invoked the tools to get the applicant's risk profile, get the list of special vehicles, bank history, loan policy. If I click on any of the tools here, if I click on this link here, it goes back and links to my run history, and you can then see the inputs and outputs for that execution. And finally, the agent gives a summary of the decision where the entire summary is given and the risk profile is low and everything, and hence the final decision that the application was auto-approved without looping in the human agent here. Now let's come to a second
Probably have to skip the one where it's going to fail and go to human. So we're almost we're out of time. So
okay. All right, so yeah.
There was one more demo that she was going to show, which was literally the case where the AI could not do the task, and it was going to defer to the human
agent to approve or
to go approve or make the final decision on that stuff. So, but still, I think this is very cool that you built all those tools. The AI can basically run those tools on your behalf. It's the coolest Logic App feature I've seen in yet.
Yeah.
Okay, if the slides come back. Oh. Just wanted to land on, if you want to learn any more about all the stuff we just showed, take a screenshot of this. This is all the talks at Build this week that are related to the content that we showed today. And I just want to say thank you for, I'll go back, I'll leave it there. People aren't fast with their cameras, but I just want to thank all my demoers in the front row. Great tech. Thank you, folks.